Hi, everybody. You guys are going to be working on this set of questions with solving algebra equations. And my paper might look a little bit different from yours, but I wanted to walk you through a couple of these examples, and you can follow along on your paper and enter them into the video as you go. So we are starting with one-step equations, meaning that there's just one thing you have to do to find the solution. Remember, the goal of solving equations is to find the missing value. So there's a variable somewhere in your equation, and you're trying to figure out what the only value that will make this equation true is. And you're trying to figure out what that missing value is. So to do this, you need to isolate the variable. Isolate meaning get it all by itself. And we're going to be using inverse operations. We've mentioned inverse operations before once or twice, so let's talk about what that means. Inverse operations would be the opposite of the operation. So instead of adding 23, you would subtract 23. Though you could also add negative 23. That would also be the opposite. Instead of adding a positive 23, you could add a negative 23. Instead of subtracting 18, you could add 18, because that's the inverse or the opposite. Instead of multiplying by negative 15, you would divide by negative 15. Some kids get confused on that one. They think that the opposite of multiplying by 15 would be multiplying, or the opposite of multiplying by negative 15 would be to multiply by positive 15. But that's why it's the inverse operation, because you're changing from multiply to divide. Just like you change from divide to multiply. So instead of dividing by 8, you would multiply by 8. So when you are doing problems like this, when you're trying to solve these types of problems, zoom in a little bit. When you're trying to solve these kind of problems, it is really important to get in the habit of writing down the inverse operations, showing your work, not just so that you can communicate to other people that are looking at your work, like your teacher, but so that you can stay organized in what you're doing. The more algebra, the more math you do, the more complicated and the more steps you're going to have in the problems that you're doing, and you're not going to be able to do them in your head. 8 times something equals 56. Most of you guys can do that in your head already, which is why on your paper, I've changed these numbers a little bit. So on my paper, x is being multiplied by 8. So first thing you have to do is you have to figure out you have to identify the variable and know that you're trying to get the variable by itself. You're trying to isolate the variable. Right now, x isn't by itself. If we want to get it by itself, we have to get rid of the thing that's next to it. To get rid of multiplying by 8, you divide by 8. And what you do to one side, you do to the other. So whatever number x is being multiplied by, you have to divide by that same number. In this case, 8 divided by 8 is 1. They cancel each other out, and I've gotten x by itself. I've isolated the variable, and then I just have to solve the math problem I created on the other side, and it's 56 divided by 8, which is 7. Yours is slightly different, so you're going to have to divide by a different number. It's a decimal. It's the kind of number that you probably wouldn't be able to do automatically in your head, so take a second right now and figure out the value for yours as well. All right, once you have figured out your answer, you can always go back and check it. We knew that 8 times something equals 56. That was the original problem. And we said that the x was 7. That was the solution I came up with. So now we check our answer to see if it still works out and equals what it's supposed to. 8 times 7 is 56. So that means we found the correct value. We figured out that it is true. Let's do another example like that. On this one, kids get confused by this one because it looks like fractions and they don't like fractions, but this is just another example of a one-step equation. A is being divided by 5. If you had a number divided by 5 and it equals 12, what would that value be? Well, we're going to do the same thing we did before. We identify where the value is, or the variable is. We figure out that it's being divided by 5. So the opposite of dividing by 5 is multiplying by 5. And if you do it to one side, you do it to the other. That's how we're isolating the variable, by doing the inverse operation. Once you know what's being done to the variable, you can do the opposite. And if you do it to one side, you do it to the other. And 12 times 5 equals 16. So let's check it. We think that the A is supposed to be 60. And 60 divided by 5 is 12. And that's what it was supposed to equal. So we know we have the right answer. So now, take a second and try a few of these problems. If A is being multiplied by 3 in this problem, to get rid of it, you're going to divide by 3. And what you do to one side, you do to the other. Once you've isolated the variable, you have found your solution. 18 divided by 3 is 6. If the variable is being divided by 4, to get rid of it, you have to multiply by 4. And if you do it to one side, you do it to the other. And when those things cancel out, you're left with B equals 12 times 4. B equals 48. And now we go back and we check our answers. The original equation was 3 times A equals 18, and we thought A was 6. So I'm evaluating my solution to see if it actually works out right, and 3 times 6 equals 18. And I can do the same thing over here. The original equation was something divided by 4 equals 12, and we decided that B is 48. So I'm substituting the value for the variable, solving, and if 48 divided by 4 equals 12, then I know I found the one answer that makes this equation true. So take a few minutes right now and go through and try the rest of these problems on your sheet and see how you do. Okay, so hopefully you did pretty well with those. Let's talk about the one additional type of one-step problem that a lot of kids struggle with. And that's when you have fractions in your equation. In order to solve these problems, they're actually really simple. There's a great shortcut. You just have to remember that multiplicative inverses can be used to get rid of fractions. So inverse just means that you're taking it and you're flipping it. Inverse is when you flip the fraction. It's also called the reciprocal. So the inverse of 1 over 3 is 3 over 1. The inverse of 5 over 7 is 7 over 5. And the inverse of 2 over 5 is 5 over 2. So now let's use the multiplicative inverses to solve the equations. So the coefficient of t in this problem is 3/5. T is being multiplied by 3/5. If I want to get t by itself, if I want to isolate that variable, I'm going to multiply it by its reciprocal, 5/3. Because when I do that, I get 15 over 15, which equals 1. Basically, those two fractions have canceled out, and I've gotten t all by itself. But whatever I do to one side, I have to do to the other. And to multiply a whole number by a fraction, I just put a 1 under it, and then I multiply. 6 times 5 is 30 over 3, and 30 divided by 3 is 10. So you just have to remember that when you're trying to get rid of a coefficient that's a fraction, you have to use the reciprocal. And the reciprocal is just the number inverted, where you flip it upside down. And if you multiply each side by the reciprocal, you'll have isolated the variable and solved for your equation. Go ahead and try this one right now. What are you going to multiply each side by to isolate the variable? hopefully you said the reciprocal of 7 over 2. That's going to get t all by itself. It's going to get rid of that coefficient. Now you have to figure out what t is, you just have to multiply these two numbers. Before you can multiply the whole number by the fraction, what am I going to do to 8? Right, put a 1 under it. So 7 times 8 is 56, and 1 times 2 is 2, and 56 divided by 2 is 28. So go through these practice problems on your own now. Multiply each side by the reciprocal. If that coefficient is 1 over 7, then I will multiply it by 7 over 1, and I do it to both sides. If the coefficient is 4 over 5, I multiply it by 5 over 4, and I do it to both sides. Make sure that you turn that whole number into a fraction so that you can find that final value for your variable. Try these out, see how you do, and we will look at these a little bit more tomorrow.